Imagine a digital vault, safeguarding every iteration of your project, ready to rewind to any past state. This is the power of a Git repository, a meticulous record keeper for your code. It captures snapshots of your project, enabling seamless navigation through its evolution. Forget the days of endless file copies, embrace the elegance of version control with Git. A Git repository is essentially a database tracking changes to your project files. It allows multiple developers to work concurrently on the same code base. This collaborative approach is central to modern software development, fostering efficiency and reducing errors. Understanding Git is no longer optional. It's a fundamental skill for any aspiring or experienced developer. Git's power extends beyond simple versioning. It provides tools for branching, merging, and resolving conflicts. These features are crucial for managing complex projects and supporting large development teams. Mastering these tools empowers developers to work independently on features, experiment with new ideas, and integrate their work seamlessly. Imagine a dedicated space on your computer, your personal coding haven where you can experiment freely without affecting the main project. This is your local Git repository. Every project you work on starts with a local repository, a safe environment to write, test, and refine your code. It's your personal sandbox before sharing changes with the team. Creating a local repository is simple. Navigate to your project directory and execute. This command creates a hidden directory, the heart of your repository. This directory tracks all modifications, acting as your project's changelog. It's important to remember that this repository is local, residing solely on your machine. Think of the local repository as your private workspace. You can make changes, experiment with new features, and even break the code. It happens, all without impacting others' work. This freedom is crucial for fostering creativity and encouraging exploration during development. Once you are satisfied with your changes, you can commit them to the local repository, taking a snapshot of your progress. While local repositories serve as your private workspace, remote repositories are the hubs for collaboration. They reside on a server, accessible to authorized team members. Think of them as the central repository for the project, where everyone synchronizes their work. Popular platforms for hosting remote repositories include GitHub, GitLab, and BitBucket, each offering unique features for managing projects. Remote repositories unlock the power of teamwork. Developers can clone a remote repository to their local machines, creating a linked copy. This allows them to work on the project independently, pulling the latest changes from the remote and pushing their own contributions. This distributed workflow is the essence of modern collaborative development. Remote repositories offer more than just code storage. They provide a platform for issue tracking, feature requests, and code reviews. These collaborative tools streamline communication within development teams, fostering efficiency and transparency. Understanding how to effectively interact with remote repositories is essential for participating in collaborative software development. The real magic of Git unfolds when we connect our local repository, our personal sandbox, to a remote repository, the central hub. This connection bridges the gap, allowing us to share our code and collaborate with others. The two primary commands facilitating this connection are and creates a local copy of a remote repository on your machine, including its entire history and branches. This command is typically used when joining an existing project or starting work on a new feature. On the other hand, is used to connect an existing local repository to a remote one. This is useful if you started a project locally and now want to share it or collaborate with others. Once the connection is established, we can start exchanging changes between our local and remote repositories. Fetches changes from the remote repository and merges them into our local branch. This ensures that our local copy stays up to date with the latest codebase. Conversely, uploads our local commits to the remote repository, making our changes accessible to collaborators. Imagine working on a new feature for your project without affecting the main codebase. Git branches make this possible. A branch is essentially a parallel version of your code, allowing you to develop independently without modifying the main branch, often referred to as the main or master branch. Creating a new branch is as simple as executing. This creates a pointer to a specific commit, marking the starting point of your branch. to start working on the newly created branch use. This command switches your working directory to the specified branch, allowing you to make changes independently. Branches are invaluable for managing features, bug fixes, and experiments. They provide a safe and isolated environment to work on new code without disrupting the main development line. Once you've completed work on a branch and it's been thoroughly tested, it can be merged back into the main branch, integrating your changes into the main code base. Once you've completed work on a branch, it's time to integrate those changes back into the main code base. This process is called merging. Git provides a powerful command to seamlessly combine changes from different branches. Merging incorporates the commits from one branch into another, effectively combining the work done in parallel. The most common scenario is merging a feature branch back into the main branch. To do this, you would first switch to the main branch using and then execute. Git will then attempt to automatically merge the changes. If the changes don't overlap, the merge will be successful without any conflicts. However, if there are conflicting changes, Git will highlight these conflicts and require manual resolution. Conflicts occur when the same lines of code have been modified in different branches. Resolving conflicts involves choosing which changes to keep, modifying the affected code sections, and then committing the resolution. While conflicts can seem intimidating at first, Git provides tools and clear guidelines for resolving them effectively. Conflicts are an inevitable part of collaborative development. They occur when two or more developers modify the same lines of code in different branches. When these branches are merged, Git flags these discrepancies as conflicts, requiring manual intervention to decide which changes should prevail. While initially daunting, resolving conflicts is a manageable process with Git's guidance. Git provides clear visual cues within your code editor, highlighting the conflicting lines and the changes from each branch. You can choose to accept the changes from one branch to the other, or combine them manually. It's crucial to communicate with your team members when conflicts arise, discussing the best resolution to ensure code integrity. Once you've resolved the conflicting lines, you need to stage and commit the changes, just like any other modification. This commit acts as a record of the conflict resolution, preserving the decision-making process for future reference. Understanding how to resolve conflicts efficiently is essential for maintaining a smooth and collaborative development workflow. A well-maintained Git repository is a thing of beauty, a clear and concise history of your project's evolution. Achieving this clarity requires adhering to best practices, ensuring your repository remains a valuable asset rather than a tangled mess. These practices involve clear commit messages, descriptive branch names, and a strategic approach to branching and merging. Start with meaningful commit messages. Each commit represents a snapshot of your project, and its message should clearly describe the changes made. A good commit message is concise yet descriptive, explaining what changed and why. Avoid vague messages like "fixed some bugs" and instead opt for specific descriptions like "fixed issue hash 123, improved error handling and user authentication." Next, adopt a clear branching strategy. Feature branches should be used for developing new functionalities, bug fix branches for addressing specific issues, and release branches for preparing stable versions of your software. This structured approach keeps your repository organized and makes it easier to track the progress of different development streams. Git's influence extends far beyond the realm of software development. Its robust version control system has found applications in diverse fields, from managing website content to collaborating on academic papers and even tracking changes in legal documents. This widespread adoption speaks volumes about Git's versatility and adaptability. Consider the world of web development. With Git, developers can seamlessly manage website updates, track changes to HTML, CSS, and JavaScript files, and revert to previous versions effortlessly. Platforms like GitHub have become the go-to platform for hosting website code, enabling easy deployment and collaboration among developers. In academia, researchers leverage Git to collaborate on papers, track changes, and maintain version history. This ensures everyone involved is working on the latest version, simplifying the process of co-authoring and peer review. Similarly, legal professionals are adopting Git to manage contracts, track amendments, and maintain a clear audit trail of modifications, improving transparency and accountability. Git truly shines when employed in a team setting. Its distributed nature empowers developers to work concurrently on different aspects of a project without impeding each other's progress. This parallel workflow, combined with robust branching and merging capabilities, makes Git an indispensable tool for collaborative software development. Effective communication is paramount when collaborating with Git. Regularly pulling changes from the remote repository ensures your local copy stays up to date, reducing the likelihood of merge conflicts. Clear and concise commit messages are crucial for informing teammates about the changes you've made. Code reviews are another essential aspect of team collaboration with Git. Before merging changes into the main branch, it's crucial to have other team members review the code, ensuring its quality and adherence to project standards. Platforms like GitHub and GitLab provide integrated tools for code review, facilitating seamless collaboration and knowledge sharing within development teams. In the ever-evolving landscape of software development, Git has emerged as an indispensable tool, a cornerstone of modern development practices. Its ability to track changes, manage versions, and facilitate collaboration has revolutionized the way software is designed, built, and deployed. Mastering Git is no longer optional. It's a fundamental skill for any aspiring or experienced developer. Embracing Git empowers developers to embrace a more efficient and collaborative workflow. The ability to experiment freely on branches, merge changes seamlessly, and track the entire history of a project fosters a culture of innovation and continuous improvement. Moreover, Git's widespread adoption ensures that developers can seamlessly transition between projects and teams, armed with a universal skill set. As you delve deeper into the world of Git, remember that its complexity is a reflection of its power. Don't be intimidated by the initial learning curve. Embrace the challenge and reap the rewards of mastering this essential tool. With dedication and practice, you'll unlock the full potential of Git, transforming your approach to software development and opening doors to endless possibilities.